Good day and welcome to ENSMAG13E, section E06. Today, we will discuss about the plane figures in solid mensuration. Last night, I was able to give you the introduction to this topic, and to refresh our minds, the solid mensuration deals primarily with the various solids. The succeeding formulas we are going to discuss are used extensively in railway engineering, in road and bridge construction, in chemical and physical analysis, and in a large variety of commercial and engineering projects. As we study solid mensuration, we shall see how necessary it is to have a thorough knowledge of the mensuration of solids. It is not enough that we only know the formulas, but also we have to learn its application. Especially we are using this widely in engineering. We might consider this as a step higher than trigonometry since we will employ its basic theorems. One example is the Pythagorean theorem. In mensuration of plane figures, we have three common mathematical terms vital to different engineering application. So the three terms are the perimeter, the circumference, and the area. Perimeter may be used either for path or its length in one dimension. It can be thought as the length of the outline of a shape. And in curved figures like circle or ellipse, the term circumference is used. Area is the amount of space inside the boundary of a flat two-dimensional objects. The area of a figure is the number of unit squares that cover the surface of a closed figure. So here, for our basic shapes, I'm gonna show you the square and the rectangle. We already know that squares have four equal sides. Here in the figure, it is labeled as A. Since all its sides are equal, so four sides of your square is considered to be A. Your P here stands for the perimeter. Since the perimeter is the length, the total length of the enclosure, so we simply sum up all the sides of your square, giving us 4A as our perimeter. Whereas your area, or the letter A here, the capital letter A, this refers to the area of your space. So we simply multiply A by A, giving us A squared. For your rectangle, we have two parallel sides, two pairs of parallel sides. So we have the longer side and the shorter side. To determine the parameter of our rectangle, we simply sum up the two parallel sides A and the two parallel sides B, giving us the formula of our perimeter equal to 2A plus 2B. For the value of its area, we simply multiply A and B. Next figure is a right triangle. We can say that this one is a right triangle, or we can say that a triangle is a right triangle if it has a 90-degree angle. So here in our figure, your 90-degree is between your leg A and leg B. And your C here is your hypotenuse. So for the right triangle, to solve for its perimeter, we just sum up your two legs, legs A and B, and the hypotenuse C, giving us the formula of your perimeter equal to A plus B plus C. And to solve for its area, we use the formula 1/2 A times B. And to give us a review on the formula of the Pythagorean theorem, we have here C squared is equal to A squared plus B squared, or simply, the square of the hypotenuse is equal to the sum of the squares of its legs, giving us A and B as your legs, C as your hypotenuse. But there are times wherein we have a missing leg. Let's say we don't know the length of leg A. So we can simply modify, or we can simply manipulate the Pythagorean theorem formula to give us A squared is equal to C squared minus B squared. By applying the values now, we can get the value of your A. Okay? Next is an oblique triangle. So for oblique triangles, or those with no right angle, we simply use the formula for the perimeter. Again, we just have to add the leg A, leg B, and leg C here. And usually in our oblique triangles, we have the value of your h, or the height of your triangle. Now to solve for the perimeter of your oblique triangle, we just have to add A, B, and C. For the area, we use 1/2 base times height, or area is equal to 1/2 A times B times sine theta. So the first formula, the 1/2 base times height, is only applicable for oblique triangles with given base and height. The second formula, 1/2 AB sine theta, can be used if we are given two sides with the adjacent angle. But for an instance, we do not have the value of the angles or the height, but we have the lengths of its three sides, we may use Heron's formula. Since we were not able to include the Heron's formula in the PowerPoint, I'll just have to send it to our group chat. Our next shape is the parallelogram. The parallelogram is somewhat similar to rectangle, but at times it has no right angles. Well, your rectangle is actually a parallelogram since its two opposite sides are parallel. But for this common idea of parallelogram with angles not equal to 90 degrees, we may use this formula. So, for the perimeter of your parallelogram, again, we just have to add the two pairs of parallel sides. So, if this is A, this side, the parallel to it, is also A. If this is B, the side parallel to it is also B, giving us the formula for our perimeter equal to 2A plus 2B. And for the area, we have base times height. That is, if our height of the parallelogram is given. But if our parallelogram has an angle, the interior angle theta, we can also use the formula AB sine theta. Our next shape is your trapezoid. So trapezoid is a quadrilateral with only one pair of parallel sides. The sides that are parallel are referred to as the bases. So we have the top base and the bottom base. The other sides are called the legs. So in our figure here, your A and your B are parallel to each other. So your A and your B are considered as the base of your trapezoid. Your other two legs, C and D, they are the legs of your trapezoid. So for your trapezoid, in computing the perimeter, we just have to add A plus B plus C plus D, or that is the sum of the legs and the base of the trapezoid. For the value of its area, we have to add first the bases. So that is A plus B times your H times 1/2. In our formula of your area, you can see there that it's like we are trying to solve first the average of your base. Then we multiply it with your height. That is your H. Okay? Our next figure is circle. So circle is a round plane figure whose boundary, or the circumference, consists of points equidistant from a fixed point, that is, the center. So if we have a common length fixed at a point, and we rotate that length, or what we usually refer to as the radius, we will create a circle. So the one we are referring to as equidistant is actually the radius here. So your radius is fixed at the center. So your radius being rotated having the same length will create a circle. To refresh our minds again, r here refers to your radius, which is equal to half of the diameter, which is your letter D. So, since circle is a curved figure, the value of its circumference is equal to pi d. Since also that your d, or the diameter, is twice your radius, we can also solve the circumference by using 2 pi r, or twice the radius times pi. For its area, using your diameter, we have 1/4 pi d squared. If we are to use the radius, the area is equal to pi r squared. Our next figure is an ellipse. So in mathematics, an ellipse is a plane curve surrounding two focal points, such that for all points on the curve, the sum of the two distances to the focal point is constant. So here we have A and B. The A and B refers to its axis. A is the semi-major axis and B is the semi-minor axis. It is called as minor and major depending on its length or its arrangement. So, semi, because your A here is just half of the total axis, half of the total major axis. So the value of your major axis is actually 2A. For your minor axis, you have also 2B. And to solve for the circumference of your ellipse, we will use the formula 2 pi times the square root of a squared plus b squared over 2. To solve for the area, we simply multiply your pi and your semi-major axis and the semi-minor axis, or area is equal to pi a times b. Now, let's move on to our sample problems. So, solve for the perimeter or the circumference and the area of the following shapes. So, our first shape is a rectangle with sides 5 cm and 3 cm. cm stands for centimeters. To solve for its perimeter, we will use the formula P is equal to 2A plus 2B. Since our sides here are 3 and 5, the pairs of parallel sides must be added. So, giving us 2 times A, wherein our A is 3, plus 2 times B, wherein our B is your 5, giving us 2 times 3 equal to 6, and 2 times 5 equal to 10. So, the total value of our perimeter is 16 centimeters. Now, to solve for its area, we will use area is equals to A times B. That is 3 times 5. Since we multiplied, it will give us a value of 15 square centimeters. So just a reminder, please be careful in indicating your units. Make sure that the units of all the sides are the same. So in our example here, we have centimeters. So only those with the same units are to be combined, are to be multiplied. Our next shape is a circle with diameter 10 cm. So to solve for its circumference, we may use the formula C is equals to pi d, giving us C is equal to pi times 10, giving us the value as 10 pi. For the value of its area, we can use the formula A is equals to pi r squared. But remember that your radius is half the length of your diameter. So if our diameter is 10, your radius is 5. So giving us pi times 5 squared, or that is 25 pi square centimeters. Our next shape is an ellipse with values of 4 inches and 3 inches for its axis, for its semi-major and semi-minor axis. So we will use the formula C is equals to 2 pi square root of a squared plus b squared over 2. In our problem here, the value of your a and b are 4 and 3 respectively. So this will give us 4 squared, which is equal to 16, plus 3 squared equals to 9, will give us equal to 25. So inside your radical sign, we have 25 over 2. To simplify this one, your numerator 25 is a perfect square. So the square root of your 25 is 5, giving us 2 pi times 5 over square root of 2. In order to remove your radical sign in your denominator, we will multiply this one with square root of 2 over square root of 2, which is just equal to 1, giving us the final answer of the circumference of your ellipse, 5 square root of 2 pi inches. For the value of its area, we simply multiply pi, a, and b. So the area now is equals to pi times 3 times 4, giving us the answer for the area of your ellipse as 12 pi square inches. Your next shape here, so this problem is a composite figure, a combination of a semicircle and a right triangle. So this one is a right triangle because of this sign. Whenever you see a triangle with that sign, that means that that angle is 90 degrees. Please don't forget that in computing the perimeter and the circumference, be sure to identify the outer boundary. So here, the triangle have its third leg connected with the diameter of the semicircle. So this portion, this one, must not be included as outer boundary, for they are inside the shape. To determine the total perimeter, this one, the total perimeter, that is equal to the perimeter of the outer boundary of your triangle, this one, and the outer circumference of your circle, giving us the equation total perimeter equals to the outer circumference of the semicircle and the perimeter of the outer triangle. So first, let us solve for your POSC, or that is the outer boundary or the outer circumference of the semicircle. Since this one is only half, so what we will do is we divided by 2 the value of your circumference. Again, the formula for your circumference for a full circle is equal to pi d. Since here, we are considering only a semicircle, so the formula is 1/2 of your pi d. The value of your diameter here is 8. So, giving us 1/2 times pi times 8 meters. So, you might be asking, sir, how sure are we that your 8 is the diameter? What if this is just a segment of a circle? Here in your figure, you have the dot. So, your dot in your semicircle refers to the center of your circle. So, because of the dot, we are sure that this is a semicircle with diameter of 8 meters. Now, the total value of your POSC is equal to 4 pi meters. So, we already have the first part of your perimeter, your POSC. Now, let's move on for the computation of your P, outer boundary of your triangle. Since we are considering only the outer boundary of your triangle, we have here this side and this side. So in our right triangle, again, this is a leg. Those two sides adjacent to your right angle is your leg. And this one opposite to your right angle is your hypotenuse. So in our problem here, we consider the side 1 or the first side as the leg, this one. So your leg is equal to 12 meters. Now, we will solve for side 2. Since your side 2 is the hypotenuse, we will employ or we will use the Pythagorean theorem. I know you are aware of the Pythagorean theorem. So that is c squared is equal to a squared plus b squared. So we are concerned of the value of your c. So this will give us the square root of a squared plus b squared. Your b here is 12. Your a here is 8. Because your 8 and your 12 are the legs of your right triangle. So the total value of the perimeter of your outer triangle is 26.42. Next, to solve for the total perimeter of your composite body or composite shape, we will sum up the outer circumference of your semicircle and the outer boundary of your triangle, which is 4 pi plus 26.42, giving us the answer approximately 39 meters. Now we will compute for its area. Since we have again a triangle and a semicircle, the total area refers to the area of the semicircle plus the area of the triangle. So for the area of your semicircle, that is just half of the area of a full circle, giving us 1/2 pi r squared. And for the value of your r, that is 4, which is half of the diameter, your radius is half of your diameter, giving us 1/2 pi times 4 squared. So 4 squared is equal to 16. 16 times 1/2 will give us 8. And with the presence of your pi, our answer for the semicircle, area of the semicircle, is equals to 8 pi meters squared. Now, for the area of your triangle, we know the formula is 1/2 base times height. In your triangle here, 12 refers to your base, and 8 here refers to your height. So, the formula is 1/2 times 12 times 8, giving us 48 square meters. Now, for the total area of the composite figure, we sum up 8 pi and 48, giving us the answer of the total area equal to 73.13 square meters. So that ends our discussion for today. Later, I will be sending a file for practice solving about plane surfaces. Also, I will give in advance a problem set for the next topic, which is the rectangular coordinates. So if you have any more concerns, please refer to our group chat and you are free to ask me anytime. So thank you for listening and have a blessed evening, everyone.